Most new homes in Australia are now required to be designed and constructed to achieve a minimum of a 6-star energy rating. So what is a 6-star energy rating and why is it important? In simple terms, the energy efficiency rating refers to the amount of energy required to heat or cool a home throughout the year. The less energy required to maintain a comfortable indoor temperature from appliances such as heaters and air conditioners, the more efficient the home is and the higher the star rating that can be achieved. The star rating scoring system ranges from 0 to 10, with 0 stars indicating the lowest efficiency and 10 stars the highest efficiency. Engineers and other suitably qualified people are able to assess and provide a star rating to most house designs, and there are 3 commonly used methods to make an assessment. Regardless of the method used, when an assessment is undertaken, there are several core areas of a house design that are assessed, and these include the material used for walls, roofs and floors, window glazing, insulation levels and type of insulation used, the building size and layout, climate zones, and the building orientation. If building a new home, the easiest way to achieve a 6-star energy rating will be to consider these items early in the design phase and incorporate them into your design, rather than leaving them as an afterthought. So let's briefly look at some of these items. Insulation. Insulation is any material that reduces the amount of heat transfer, hot or cold, to and from your home through doors, windows, ceilings, floors and gaps. Insulating your home will keep your home warm in winter and cool in the summer. Common ways of insulating your home are by adding insulation into your roof and ceiling spaces. Drafts can be reduced by sealing around windows, doors, floors, ceilings, and filling any gaps in walls. House orientation. The orientation and location of your home will impact the amount of natural heating, cooling, and lighting your house may receive. Your house should be oriented on a site to maximize the amount of winter sunlight it receives. Ideally, a house location that enables the daytime living areas facing north with the long axis of the house running east to west is best. Because of the low angle of the sun in winter, large windows on the north side of your house are preferred to let sunshine in, whilst eaves above the same windows limit the entering sunshine in summers when the angle of the sun is high. When choosing the location of your home on your chosen site, also consider the effects of overshading from neighbouring properties and trees, particularly for buildings and trees located to the north. Building layout. We've already noted that daytime living areas should ideally be facing north to capture the sunshine through large windows, while bedrooms and other rooms should ideally be designed to be located on the south side of the building. Generally, the most energy-efficient house plans are based around open-style living areas that make best use of available space, allow sunlight to easily enter, and allow air to circulate freely throughout the home. However, open areas should be designed with doors that can be closed to partition one area or room from another to minimize the amount of heating and cooling as required in each individual area. Building materials. When building materials are being considered in the assessment process, the assessor is really examining the building's ability to store heat. The ability to store heat is also known as a material's thermal mass. A material with high thermal mass can store large amounts of heat without a large temperature change. And examples of such types of materials and structures are bricks and masonry walls, concrete slabs, or floors with hard floor coverings. In places where the difference between day and night is 8 degrees or more, correct use of thermal mass can keep internal temperatures at a moderate level by averaging day and night extremes. For example, concrete, tiled or slate floors can absorb heat during the day in winter months and then release the stored heat into the room at night. The use of carpet and rugs as insulation can prevent the floor from absorbing heat in the summer. Windows and shading. More heat is gained and lost through windows in an average insulated home than through any other aspect of the house design. Choosing the right size windows and the right size glazing material can significantly improve the comfort of a home. Shading is an effective way to keep a house cool in the summer, but needs to be well designed so that it does not block out winter sun, which can help provide heat in the winter. Ideally, all north-facing windows should be full length to allow heat from the winter sun. East and west-facing sides should have minimal areas of glass, or none at all. As a general guide, the total window area should be less than 25% of the total floor area of the house. As a further guide, the percentage of window areas to wall area for each direction is north-facing 60%, south-facing 30%, east-facing 15%, and west-facing 0 to 7%. We've briefly covered some of the important areas that should be considered when designing your home that will greatly influence the house energy efficiency and the ability to achieve a 6-star or above energy rating. We hope you have found this presentation helpful, and for further information and advice, please contact FMG Engineering.